Hey folks, welcome to Chapter 1, Lesson 5, Angle Relationships. Angles 1 and 2 are adjacent angles. Let me give you my definition first. Adjacent angles are angles that are right next to each other. They share a common side. Easy. Now let's look at the book's definition. They lie in the same plane and have a common vertex and a common side, but no common interior points. In other words, all the points that are interior to one are not interior to two. Angles 3 and 4 are a linear pair. Let me give you my definition first. A linear pair are two adjacent angles, which you recall from the last slide means they have a common side. They are right next to each other. And their angle measures, if you total them up, sum up the angle measures, will be 180 degrees. Now let's look at the book's definition. They're a pair of adjacent angles, right? We know what that means. With non-common sides, here are the non-common sides, that are opposite rays. What happens if you have two non-common sides that are opposite rays? They form a line, and that indicates a straight angle, which is 180 degrees. Angles 5 and angle 6 are vertical angles. Vertical angles are two non-adjacent angles formed by two intersecting lines. The only way to get vertical angles is cross two lines and you get an intersection point. While the angles that are opposite from each other, like angle 5 and 6, or angles 7 and 8, are called vertical angles. They're always congruent to each other. Once again, to get vertical angles, you cross two lines, you get an intersection point. The angles that are opposite from each other are called vertical angles, and they're always congruent. Look at the book's definition. They are two non-adjacent angles formed by two intersecting lines. So what do they mean by non-adjacent? Well, 7 and 6 are adjacent, but 5 and 6 are not adjacent. Those are the vertical angles. All right, we have some cheerleaders doing a stunt. Name an angled pair that satisfies each condition. Two acute adjacent angles. Do you remember what acute adjacent angles are? They are angles with a measure between 0 and 90 degrees, not inclusive of 0 or 90, and they're angles that must be right next to each other. That's what acute and adjacent means. All right, well, OJN, OJN, and MJN, MJN, both acute angles, and they share a common side, so they're adjacent. But two obtuse vertical angles. Obtuse angles have an angle measure between 90 and 180 degrees, not inclusive of 90 or 180. And vertical angles, you remember, are formed by the intersection of two lines, and the opposite angles, the non-adjacent angles, are the vertical angles. Okay, why don't we try HJN, HJN, and KJM. Notice both are obtuse, and they clearly are formed by the intersection of two lines. They're not adjacent, therefore they are vertical. How about a linear pair? Remember what a linear pair is? Yes, adjacent angles that have an angle some measure of 180 degrees. What about HJK, HJK, and KJM, KJM? Notice HJK is a line, so HJK and KJM are adjacent angles with an angle sum of 180 degrees. Finally, two acute vertical angles. Well, HJK and NJM are clearly vertical angles, and they're acute. Easy. All right, you need to know that vertical angles are always congruent. So 5 is congruent to 6, and 7 is congruent to 8. A couple more definitions. Angles 9 and 10 are complementary angles. because they have an angle sum of 90 degrees. Angle 9 plus angle 10 equals 90 degrees. Angles 3 and 4 are supplementary angles, meaning the sum of their measures is 180 degrees. The measure of angle 4 plus the measure of angle 3 equals 180 degrees. All right. Word problem. Find the measures of two supplementary angles if the difference in the measures of the two angles is 18. All right, how do we handle any word problem in this class? First, you convert from this language, which is verbal, to the second language, which is geometry. And then from geometry, you convert to translate to algebra and then solve. So the system is verbal, which is what you have going on right here, verbal, translate to geometry, translate to algebra, solve. All right, let's translate to geometry. Find the measures of two supplementary angles. Supplementary angles total 180 degrees, so it's probably going to look something like this. Angle 1 and 2 sum to 180 degrees, as you can see. Also, we're told that the two angles have a difference in their measure of 18 degrees. So they're not going to both be 90-degree angles. One's going to be smaller than the other. Angle 1 slightly bigger than angle 2. All right, we have converted from the language called verbal to the language called geometry. Now let's convert to the language called algebra. How am I going to do that? I'm going to create some equations. Is there an equation we can conceive of straight from our geometry? Well, yeah, the obvious one is angle 1 plus the measure of angle 2 equals 180 degrees. Measure angle 1 plus the measure angle 2 equals 180 degrees. There's a second equation that you can come up from the words. And what is it? You can come up with this equation. The measure of angle 1 minus the measure of angle 2 is equal to 18 degrees. Where did we get that from in the verbal? The difference in the measures of the two angles is 18. The difference in the measure of the two angles is 18. The difference, you remember, is the answer to a subtraction problem. All right, we have two equations that we got from two facts from our verbal. We now have a system of equations, and the way you indicate that is with this bracket. And there's two ways to solve a system of equations. One is substitution, the other is elimination. Substitution may be easier, but elimination is much more useful, especially as we get to larger systems. So let's learn both methods. In this case, we will solve the system by elimination. How do we do elimination? Do you remember from last year? All right, your options are add the first equation to the second equation, get a third equation. You could take the first equation and subtract the second equation to get a third equation. Or you could take the first equation and add it to some multiple of the second equation, like multiply the second equation by 3 and add the first and the second equation to get a third equation. That's elimination for you. Here, we are going to add the two equations. All right, let's start. What is the measure of angle 1 plus the measure of angle 1? 2 measures of angle 1. What's 1 apple plus 1 apple? 2 apples. What's the measure of angle 1 plus the measure of angle 1? 2 measures of angle 1. All right, let's add these guys. The measure of angle 2 minus the measure of angle 2. What's that equal? 0, right? Negative 25 minus 25 equals 0. I just made up the number 25. And then add these two numbers together, 180 plus 18 is 198. What have we achieved? We have gone from two equations in two variables. Measure of angle 1 and the measure of angle 2 are two different variables, right? Two equations, two variables, to one equation and only one variable, the measure of angle 1. Much easier to solve. All right, so what do we do to both sides? Divide by 2. we get the measure of angle 1 is 99 degrees. Kind of seems right to us, right? 90 degrees would be right here. So 99 seems about right. Are we done with the problem? No, we're asked to find the measures of two angles. So what are we going to do with the measure of angle 1? You're going to plug it back into either of these two equations to get the measure of angle 2. All right, I'll plug it back into that first equation. In place of the measure of angle 1, I'll put 99. The rest is the same. All right, and then I just solve, and I get the measure of angle 2 is 81 degrees, which seems reasonable. Here's another word problem. Before we read it, if it's in the verbal language, you're going to translate it to geometry, then to algebra. Good. Find the measures of two complementary angles if the measure of the large angle is 12 more than twice the measure of the smaller angle. Let's convert to geometry. We notice that the two angles are complementary, which means their angle sum must be 90 degrees. In addition to that, we see that the large angle is 12 more than twice the measure of the smaller angle. So the large angle is bigger than, 12 bigger than, twice the smaller angle. All right, something like this. There's our complementary angles summing up to 90 degrees, and we can see that the bigger angle is more than double the size of the smaller angle. Good. Convert to algebra. Well, what's the obvious two equations that you're going to get from two facts? What's the first and most obvious fact? You can see it in your geometry very easily. Angle 1 plus angle 2 equals 90. A measure of angle 1 plus the measure of angle 2 equals 90 degrees. What's the less obvious fact, but it's still clearly in the verbiage? It says the large angle is 12 more than twice the measure of the smaller. The measure of angle 1, which is my larger angle, is twice the measure of angle 2 plus 12. The large angle is 12 more than twice the smaller. The larger angle is twice the smaller plus 12. You see it? What do we have now? This is called a system of equations. And how do you identify that? With this bracket. Now you have a system of two equations in two variables. The variables are measure of angle 1 and measure of angle 2. That's pretty tough. However, you can easily boil this down to one equation of one variable, and that's what we're going to do. All right, how are we going to do it? Well, we could do elimination, or we could do substitution. Since we did elimination in the last problem, let's do substitution here. Substitution is just like it sounds. You are going to substitute something in place of one of these angles. In this case, in place of measure of angle 1, I'm going to substitute this right here. Do you see the measure of angle 1 equals to measure of angle 2 plus 12? So I'm just going to stick this right here in place of this right up here. That's all I did. All right. 2 measures of angle 2 plus 1 measure of angle 2 equals 3 measures of angle 2. And then bring the 12 to the other side to get 78. Divide by 3, and you get the measure of angle 2 is 26. Are we done? Nope. We still need to get the other angle. How do we do that? Plug the measure of angle 2 equals 26 into right here or right here. Either one will get you the angle, measure 1. I plugged it into the first equation, and I got whatever that is. All right. Some more definitions. These lines right here are called perpendicular lines. They're perpendicular lines because when they intersect and form vertical angles, those vertical angles are going to be right angles. So instead of just two pairs of vertical angles, I have 4 right angles. Perpendicular lines, when they intersect, form 4 right angles. We write this. Line AD is perpendicular to line BC. That's the symbol. Now you can have rays and can be perpendicular to lines. Segments can be perpendicular to line segments. You can do all that. All right, and this right here is the universal symbol for a right angle. We have a word problem. Find x and y so that line PR and line SQ are perpendicular. Do we remember what perpendicular means? It means that the two lines intersect to form what? Right angles, 4 right angles. Each one of these are right angles. All right. Can you think of any equations that should be clear coming off of the geometry together with the verbal? Let's go to algebra. We have the geometry and verbal. Geometry, verbal. Let's go to the algebra. The first thing you should probably see is that angle PTQ is a right angle, so its angle measure is 90 degrees. We also know its angle measure is 4y minus 2. So we can say 4y minus 2 equals 90. Now it's an equation of one variable, so we just solve the unknown, and we get 4y equals 92, and y equals 23. Great. Now we can repeat the process down here. Angle STR is clearly a right angle, a 90-degree angle, since these lines are coming together perpendicular. Well, a small angle plus the other small angle should equal the big angle. 2x plus 5x plus 6 should equal 90. All right. Divide by 7, you get x equals 12. So we solve for x and y. Notice this is not a system of equations. It's two totally separate operations, one to find x and one to find y. All right, one more word of warning about intersecting lines. Just because they look perpendicular doesn't mean they are. Your word problem, the verbal, has to say they're perpendicular, or the geometry has to have that universal corner symbol to say that you have a right angle. If you have a right angle, then you're perpendicular lines. You just can't assume it just because the picture looks like it might be right angles. How do you know? Maybe these are 89 degrees and 91 degrees instead of all 90. Your eyes aren't clear enough to tell that. All right, next. Your book has this pretty cool diagram. It says what can be assumed and what cannot. Very important. It says HM and HL, HM and HL. You couldn't assume they're perpendicular. No way. Just because they look like they might be 90 degrees. In fact, they don't even look like they're 80. But you can't just say, they approximately look like that. That's not a thing. All right. You can't assume that JHK, and GHM are congruent. I mean, they look like they are, right? Doesn't those two look like they were drawn to be congruent? Same size angles? Yeah, but you can't assume that. They haven't given you a little arc that of the same number of arcs, like don't have one arc here and one here, or 2 arcs here and 2 arcs here to indicate congruency. They didn't tell you anywhere. So you can't just eyeball and say, oh, therefore they must be congruent because they look that way. Do you see what you can and can't do? All right, let's move on. Determine whether each statement can be assumed from the figure or not. Angle DBC and angle ABG are complementary, meaning they sum up to an angle measure of 90 degrees. The answer is no. They don't even look like they sum up to a measure of 90 degrees. But you can be sure they don't because this right here we know is 90 degrees, and there's still this extra angle in here. So there's no way if you summed up these two you'd get 90 degrees since this total measure is 180. Angle, we do know, however, that they're congruent. You can see that because this little single arc, the two single arcs indicate congruency. All right, ABD and CBD are a linear pair. ABD, DBC, yes, they're a linear pair. They have a common side, they're next to each other, and their total, if you sum up their angle measure, is 180 degrees. Okay, how about ray BF is perpendicular to ray BG? Yes, definitely. There's a right angle here as indicated by that symbol. All right, let's go on to 4A at the bottom. ABF and FBC are supplementary, meaning their angle sum is 180 degrees. Well, the answer is definitely yes. This angle plus this angle definitely equals 180 degrees. How about ABG and GBD are adjacent angles? Yes, they're right next to each other. They share this common side. All right. Name an angled pair that satisfies each condition. Two acute vertical angles. Well, how do we find vertical angles again? You look for crossing lines. Can you see crossing lines here at all? Yes, as long as you hide this line. If you delete this line from your brain right now and just focus on these two, if you delete this ray from your mind and just focus on these two lines, you'll see that they're intersecting, forming vertical angles here and here. And this angle are both acute. These are acute vertical angles. So WVU and YVZ. All right, how about two obtuse adjacent angles? Well, how about UVZ, UVZ, that's clearly obtuse, and XVZ, XVZ. So we have UVZ and XVC. They have this common side, and they're both obtuse. That works. Camera lenses, we're into number 3. Cameras use lenses and light to capture images. We have the picture of a cat, meow, and the capture of a picture of the reflected small cat on the film. What type of angles are formed by the object and its image? Well, angles 1 and 2 are what? Vertical angles. The intersection of two lines. If the measure of angle 2 is 15 degrees, what's the measure of angle 1? 15 degrees, because these are vertical angles, which are always congruent. All right, algebra. The measures of two complementary angles are 7x plus 17 and 3x minus 20. Find the measures of the angles. The algebra should not be showing right now what it is. So let's just go straight from the verbal, which is all you should have, to the geometry right here. The measure of two complementary angles. So I mean, if they're complementary angles, then angle 1 and angle 2 must sum to 90 degrees. Okay. And so we'll call the first angle angle 1, the second angle angle 2. We know that angle 1 is a measure of 7x plus 17. We know that angle 2 is a measure of 3x minus 20. All right, I basically translated from verbal to geometric. Now from geometric, we'll go to the algebra, which you shouldn't be seeing yet, but you are. The obvious fact from the geometry here is that the measure of angle 1 plus the measure of angle 2 should equal 90 degrees. 1 plus 2 should equal 90 right here. Well, that's angle 1, that's angle 2's measure. Add them together, you get 90. So that means x equals 9.3. Are we done? No. Or we just have x, but we want to find the two angles. So we plug x equals 9.3 into the first angle and the second angle, to the first angle and the second angle. All right, plug 9.3 into the first angle, you get 82.1, and if you plug 9.3 into this second angle, you get 7.9 degrees. Perfect. Lines x and y intersect to form adjacent angles, 2 and 3. Okay, so any pair of intersecting lines will form adjacent angles 2 and 3. We're given the measure of angle 2 is 3a minus 27. The measure of angle 3 is 2b plus 14. Find the values of a and b so that x is perpendicular to y. It seems like a lot of verbal. It might feel daunting to try to write the geometry, to translate to geometry. But you can do this, right? What you can do is just translate what you can. It's like if someone wrote the sentence, me llamo Vicente, por supuesto. You may know that me llamo Vicente means my name is Vincent. You may not know that por supuesto means of course. Um, but you could still translate the part that my name is Vincent, and you wouldn't sit there and not do anything just because you didn't know how to translate part of it. Same thing here. Don't just sit here thinking, if I can't figure out everything in my head right now, I'm going to be stuck. No, just start translating what you can into geometry. All right, we have lines X and Y intersecting. X and Y have to intersect, but they also have to be what? Perpendicular. So they have to intersect, form right angles, just like that. All right. We also know that angles 2 and 3 are what? Adjacent, meaning next to each other. So I'm going to pick two angles that have a common side. Then measure of angle 2 is 3a minus 27. The measure of angle 3 is 2b plus 14. That's all the geometry that I can write. Let's go over and do some algebra. Well, what's the obvious fact from this piece of geometry right here? That 2b plus 14 equals what? 90 degrees. And also that 3a minus 27 equals 90 degrees. So you can solve for A, and from this guy right here, you can solve for B. It's the definition of complementary. Once again, word problems can seem daunting because we have trouble translating. Just take it one step at a time so you get a nice picture, then translate from the picture to the algebra, and then you can solve. You can do this. All right. Determine whether each statement can be assumed from the figure. Explain. Angle CAD and angle DAB are adjacent, but not, sorry, angle CAD and angle DAB are complementary. CAD and DAB are complementary. Is that true? Is CAD and DAB complementary? Well, they certainly look like they are. They look like they form a right angle when you sum them up, right? Looks like this angle was 90 degrees, which would be complementary. But no, they may appear to be a right angle, but you don't know that this is a right angle. You know this is a right angle. Why? Because of the universal symbol for right angle. But you don't know this is a rectangle. This thing could be off by even a degree or two. So you cannot make that assumption. All right. EDB, and BDA are adjacent. Yes, that's true. They have a common side, right? They're right next to each other, but are neither complementary nor supplementary. That's true. There's no way that equals 180, and there's no way that equals 90. But not just because you're looking at the picture, but because you see that EDC is 90 degrees, and since this is clearly smaller than 90, which is indicated, then you know this must be not complementary and certainly not supplementary. All right, folks, your homework is to do lesson 5, numbers 9 through 47 odd. You can do this.